You ever see a poll and just kind of wonder, how can 1,000 people possibly speak for an entire country? I mean, it seems impossible, right? Well, it's not magic. It's actually a really powerful statistical method. And today, we're going to break down exactly how it works. All right, so let's get right to it. This is the big question, right? How can a poll of just 1,000 people claim to know what 300 million people are thinking? It really does sound like a trick, but it's a super powerful scientific process. And to get our heads around it, we've got to start with the most obvious way to get an answer, which, as you'll see, is also the most difficult. I mean, in a perfect world, you could just ask everyone, every single person. That's what we call a census. It's an attempt to get data from literally every member of a population. And yeah, it's the most thorough way you could possibly do it, but as we're about to see, it's almost always completely impractical. Look, a census is the gold standard for completeness, for sure. But the trade-offs, they're huge. The time and the money involved are just astronomical. I mean, can you imagine trying to survey an entire country just to see if people like a new soda flavor? It would be so slow, wildly expensive, and honestly, by the time you got your answer, it would probably be totally irrelevant. So yeah, there has to be a smarter way. And of course, there is a smarter way. It's called sampling. And the core idea behind it is actually super simple and, honestly, kind of elegant. Think about it. You don't need to drink an entire pot of soup to know if it needs more salt, right? All you need is one good spoonful. Well, in statistics, that spoonful, that's our sample. Okay, so let's get a couple of key terms straight so we're all on the same page. That entire pot of soup, that's what we call the population. It's the whole group you're interested in. Could be all the voters in a country, maybe all the high school students in a state, or even all the cars a factory made last year. It's the everyone we want to know something about. And that spoonful we talked about, well, that's the sample. It's that smaller, specific group that we actually go out and collect data from. And here's where the magic happens. If, and this is a big if we choose our sample correctly, its characteristics should pretty much mirror the entire population. That's what lets us make these incredibly accurate guesses without having to talk to everybody. And that right there brings us to the most important question of all. Seriously, everything hinges on this. When you dip that spoon into the soup, are you just getting broth, or did you get some of the meat and the vegetables too? The method you use to pick your sample, that's what decides if your results are a true reflection of the whole group or just a totally misleading snapshot. Okay, let's dive in, and we'll start with what's really considered the scientific gold standard, probability sampling. The whole idea here is using the power of pure randomness to pick a sample. Why? Because it gets rid of human bias. It's pretty much the fairest way to make sure everyone gets a voice. So the key phrase you gotta remember here is a known non-zero chance. What that really means is we're not just picking people who are easy to find or who happen to be nearby. In a real probability sample, every single person in that whole population has a mathematical chance of being included. And that's the secret sauce that lets us create unbiased estimates about the entire group. All right, so the most basic version of this is called simple random sampling. And honestly, it's exactly what it sounds like. It's like putting everyone's name into a giant hat, shaking it up real good, and pulling out a few names. Every single person has the exact same chance of being picked. It's the purest way to do it, but there's a catch. You need a complete list of everyone in the population to start with, which, yeah, can be pretty tough to get. Okay, next up we have systematic sampling, which is, you guessed it, a bit more systematic. So imagine you've got a list of 1,000 people, and you need to sample 100 of them. Simple. You just divide 1,000 by 100, and you get your interval, which is 10. Then you pick a random starting spot. Let's say you start at person number 7, and from there, you just pick every 10th person. So you'd get number 7, then 17, then 27, all the way down the list. It's a great way to make sure your sample is spread out nice and evenly. Now, this next one is really, really clever. It's called stratified sampling. This is all about making sure you hear from all the important subgroups in your population. So what you do is you first slice your population up into distinct layers, or strata. So think about a high school. You'd have freshmen, sophomores, juniors, and seniors. Then you do a simple random sample inside each of those groups. This guarantees that your final sample has the right proportion of students from every single grade level. And that's super important if you think, a freshman's opinion might be different from a senior's. But what happens when you can't get that perfect list of everybody? Or what if you just don't have the time and money for a full-on random process? Well, that's where the other family of sampling comes in, non-probability sampling. And this approach is totally different. It relies on the judgment of the researcher, not on pure chance. And make no mistake, this distinction is absolutely crucial. With probability sampling, remember, the selection is random. Everybody has a chance to be picked. And because of that, you can generalize your findings with a lot of confidence. But with non-probability sampling, the selection is subjective. It's based on choice. That means some people have literally zero chance of being picked, which makes it really difficult and frankly risky to say your findings apply to the whole population. So the most common type of this is something called convenience sampling, and you've totally seen this in action. Think about a TV reporter on the street just interviewing the first 5 people who walk by. It's super fast, it's cheap, but just think about it for a second. Who did they miss? Well, everyone at work, people at home, people who live on literally any other street. It is definitely convenient, but it's probably not very representative. And here's the critical warning you always hear about this method: inherent bias. Because the sample wasn't picked at random, the results you get might be interesting, sure. They tell you something about those specific people you talk to, but you absolutely cannot trust them to represent the whole population. It's just not built for that. Okay, so quota sampling is basically an attempt to fix the most obvious problems with convenience sampling. Here, the researcher has a checklist, a quota they need to fill. They might say, okay, I need to interview 50 men and 50 women. And then they go out and just find people until those spots are filled. So it does make sure you have some representation, but, and here's the key, the choice of who fills those 50 spots is still based on convenience, not on randomness. All right, now this method is pretty fascinating. It's called snowball sampling, and it's what you use when you need to study a group that's really hidden or hard to reach. So imagine you want to interview expert collectors of super rare stamps. You probably only know one person to start with, right? So you interview them, and at the end you ask, hey, who else do you know that I should talk to? And just like that, your sample grows. It snowballs from those referrals. It's an absolutely essential tool for studying those kinds of specific, tight-knit communities. Okay, so we've looked at the 2 big families of sampling, right? One is based on pure chance, and the other is based on the researcher's choice. Now, the crucial point for us is understanding when to use each one, and maybe even more importantly, how to evaluate the results when we see them out in the wild. So really, it all boils down to this. The method has to match the goal. If what you need is scientific accuracy that truly represents an entire population, like a major national election poll, then you absolutely have to use probability sampling. There's no way around it. But if you just need some quick and dirty feedback, something exploratory, like, say, testing a new website design, then a non-probability method might be totally fine. So, what's the big takeaway for you in all of this? Well, it's all about becoming a more critical thinker, a smarter consumer of information. Don't just look at the headline number in a poll. And please, remember this. A huge sample of 10,000 people chosen with a bad method is way, way worse than a small, carefully chosen sample of 500. Always, always ask yourself, how did they choose these people? And just as important, who got left out? And there you have it. We've gone all the way from the impossible idea of asking every single person to the really elegant solution of using a well-chosen sample. The power to judge the data you see every day is now in your hands. So, I'll just leave you with this one thought. The next time you see a poll or a study, what's the very first question you're going to ask?